guys, today we're going to talk about thinking like a scientist. Scientists always ask questions, gather data, make a hypothesis, they often conduct an experiment, observe and record results, and share those results with others. So today we're going to be talking about how scientists wonder, explore, and investigate. First, you have to start by asking a question. Why does that happen? How does that happen? Which one of these is better? Which one would work better in this situation? Does this work? Does that work? When does this occur? So you start by asking a question about something that you're interested in. Then you need to determine your purpose. What could your experiment change? By experimenting on this question, what could your results yield? What change could your experiment bring about? If you're testing two different paper towel brands, which one's better and more efficient? That's the one you're going to buy after that. So your purpose is why you're doing the experiment, what you hope to gain from it, what you hope to be able to do because of this experiment. Then you need to come up with your hypothesis. What do you think will happen? Remember, this is an if-then statement. I think if this happens, then this will happen. When you write your hypothesis, we know it's your prediction, so you don't need to say I think. It's just, if this happens, then this will happen. We know it's a prediction. To come to that prediction, though, you need to do some research and find out information about your topic. Then you make an educated prediction. You don't just go, I think it'll rain today. You go, let's go ahead and look at the data from past years. It typically rains a lot this time of year. There's lots of dark clouds outside. I predict it'll rain today. So you need to have some research and then your prediction. After you've made this, then you think about your materials. What are you going to use to test this hypothesis? Your materials need to be detailed. You need to use metric measurements like millimeters and centimeters. If you just say, get some water, well, I might get this much water, or I might get this much water. I need to know how much to grab, and scientists always use the metric system. Millimeters, centimeters, grams, liters. We shouldn't hear inches and feet and yards. All those things aren't metric, they're standard. Finally, we need to think about our variables. What are we going to change in this experiment, and what's the experiment going to change? If we think about our if-then statement, we can come up with a clue for that. If, whatever you're changing there, if this happens, that's your independent variable, I change it. So if independent, I change. Then the experiment will change this piece. That's the dependent variable. So if independent variable, then dependent variable, what the experiment's going to change. I might change the time of day I go outside to check the weather. I might go in the morning and the afternoon and late in the evening. And that will depend, my results will depend on that change that I made. I might change the temperature in the classroom. I may make it really cold, kind of warm, really hot. Then something will happen. That thing will depend on the change I made. So one more time, variables are what's being changed. Your independent variable is what I change. Your dependent variable is what the experiment changes. So if independent variable, then dependent variable. And you need to come up with a title. What can you say about your experiment that will make other people wonder what you're up to? You want them to wonder about the same questions you're asking, so that they have interest and will read about your experiment. Number 6. Now we're going to talk about the constants. We just talked about the variables, independent and dependent. The constants are the thing that stay the same. Some experiments you always check at the same time of day. So that time of day, the temperature outside isn't affecting it. You're checking it at the same time every day. Some experiments you might use the same jars. You might use the same amount of different liquids. The amount of liquid you're using is the constant. The different types, like vinegar and water, are your variables, your independent variable you're changing. Procedures. How will you test this? These again need to be detailed so that someone else can follow your directions. They need to be step by step, like you're explaining it to a kindergartner. Get out the jar of peanut butter, open the jar of peanut butter, take a knife, pick up 2 milliliters of peanut butter, spread it on. Okay, it has to be step by step and very basic, not just make a peanut butter and jelly sandwich. And we must again use metric measurements, not standard. So millimeters, centimeters, meters, things like that, and liters. Then you're going to be analyzing the data. All throughout you're following the procedures, you're going to be collecting information in your logbook. So you need to have data that's going to be collected in your logbook. You need dates, metric measurements, observations, and any changes at all to your procedure. You may have this great procedure that you set out, and then you realize, oh, this doesn't work. Let me change this step, or oh, I forgot to add this step in. Make sure you note that in your logbook, and everything in your logbook should be dated. Once you've finished your experiment and you've collected all the data you need, then you're going to make a graph. You're going to show us the data. Your dependent variable, what the experiment's changing, is going to be on your y-axis. Your independent variable, what you're changing, is going to be on the x-axis. So dependent, what you're watching, what you're measuring, independent, what you have changed. Finally, we're going to get some results. What data did you get? Did you see that this one always had more than that one? Did you see that this one was faster? What did you see? You're going to write what you saw in the graph in words or in a paragraph. Then the last step is your conclusion. This is where you share information with others. Did what you predict happen? Why do you think that happened? Why didn't it happen if it didn't happen? How else could you test this? Or what would you want to test now after this test? So there's lots of different things you can answer and discuss in your conclusion. And I need you to remember that the true scientific method gets messy. Scientists have to start over, and they don't have to do every step in order. However, they always wonder, explore, and investigate. And I hope that you have fun wondering, exploring, and investigating during this scientific process.